Section 2.3, Solving Linear Equations. So here we're going to make a step-by-step guide for solving linear equations. The first step is to simplify the algebraic expression, and this may come from two parts, maybe distributing, and maybe from combining like terms. After you distribute and combine like terms, you're going to want to get all the variables terms on one side of the equation in step 2, and then get all the terms out of variable on the other side of the equation. Next, you're going to get the variable by itself, and then you may check the proposed solution. We usually say that this step right here is optional. If you're doing a test on paper like your midterm exam, you may want to check all of your answers. When we're doing these examples in the course pack, I may check the first one, but I might skip checking the solutions on the remainder. So let's look at the first one. There's no distributes to do, but I do have some like terms that I can combine. So the like terms I see right here are the 4x and the 9x. They're on the same side, so when it says 4x minus 9x, I simply subtract like it says, and get negative 5x plus 22 equals 3x plus 30. Now, each side individually is simplified, so move on to step 2. I want to collect all the variable terms in one side of the equation. Okay, so I've got 5x here and 3x here. Let's move them all to the same side. So I'm going to subtract this 3x since it's positive from both sides. Since I'm moving it to the opposite side of the equation, I need to use the opposite operation. So this gives me negative 8x plus 22 equals 30. Now I'm going to do something similar. Here are my x's. I want to get rid of this 22. It's positive, so the opposite operation would be negative to move it to the other side of the equation. So I'm going to end up with 8x equals 30 minus 22 is 8. And finally, get the variable by itself using the multiplication property. That's negative 8x, negative 8 times x. So I'm going to divide both sides by negative 8 to get a final answer of x equals negative 1. Let's look at the next one. When I start this next one, I do have a distributive property to use. So let's distribute, and I'll distribute on this side. Okay, so I've got 5 minus 4 times 2 is 8x. Negative 4 and negative 3 multiply to a plus 12. 3 times 4 is 12. And 3 times negative x is negative 3x. Okay, so I distributed, and I'm going to go ahead and combine any like terms that are on the same side, like the 5 and the 12. So that'll give me negative 8x plus 17 equals 12 minus 3x. Alright, everything has been distributed and combined. It's been simplified. Now we're going to move the variables all to the same side. So let me go ahead and add this 3x again. I want all my x's on the same side. So negative 8x plus 3x is negative 5x plus 17 equals 12. And to get x by itself, I need to subtract that 17 from both sides. So I've got negative 5x equals negative 5, and I need to divide by negative 5 to get the x by itself. So this time, two negatives, negative 5 divided by negative 5, gives me x equals positive 1. Alright, let me go ahead and check. I didn't check the first one, I forgot. Let me go ahead and check the second one right here. This is my optional checking step. To check it, I'm going to plug that 1 into the original. So it was 5 minus 4 times 2. Here's my x, which is 1, minus 3. And I want to know if that's equal to 3 times 4 minus x, which is 1. So following order operations, this would have been 5 minus 4 times 2 times 1 is 2, minus 3. And if I simplify on the other side, that's going to be 3 times 4 minus 1 is 3. That side is 9. So now I just have to check that to see if the left side matches. So this is 5 minus 4 times negative 1. 2 minus 3 is negative 1. So that's 5. Negative 4 times negative 1 is plus 4 equals 9. And that's true. This does check. So that verifies that this is the correct answer. Okay, so again, that check step is something that on a test, if you're not sure of your answer, you may want to check. You can check in your calculator by plugging both left and right side in the calculator. Let's go ahead and see how that might have looked as well. Sorry, I'm running my calculator. Okay, so I would run this on my calculator by typing in the entire left-hand side. I would type 5 minus 4 times 2 times 1 minus 3, just like it looks on paper. Hit enter, and then I would check the right-hand side the same way and just see if they came out with the same values. This would be a way of quickly checking my calculator. I got the same thing on both sides, that it was true. You may want to check on your calculator on the test instead of checking by hand if you're worried about the answer, just so that you can do it quickly and you know that you do have the correct answer. Alright, back to the next problem. Alright, in this problem we need to distribute. So we're going to distribute 2 into that parenthesis, a negative into this parenthesis, and a 3 into this parenthesis. So we'll get 2 times 3x is 6x, plus 2 times 4 is 8, minus 4x, negative and negative will make that 1 positive, equals 3x plus 3 times 2 is 6. All of the distributes are done, so we'll combine like terms. We've got some like terms with our x's and some like terms with our constants. 6 minus 4x is 2x, and 8 plus 1 is 9. Then we've got 3x plus 6 on the other side still. Now we are ready to use the addition property to move the x's to the same side. So we can move the 2x or the 3x. I notice that if I move the 3x, minus 3x would give me negative 1x. Or if I move the 2x, subtracting 2x would be positive 1x. I'm going to go ahead and move the 2x and keep that x positive. So I'm going to subtract 2x from both sides. It gives us 9 equals 1x, and the advantage of doing it this way is that I can simply write x. I don't have to write the positive 1. I would have to write the negative if I would have done it the other way. And finishing this off with a subtraction of 6 gives me 3 is equal to x. Alright, let's look at the next page. Solving linear equations containing fractions. Alright, now there are 2 ways to go about this. The first way would be to live with the fractions and deal with them, and so that would be to take this as 5/6 k. I want to write that down, I wanted to just say it out loud. 5/6 k minus 3 halves plus 7 halves. To solve for k, you need to add 3 halves to both sides. Oops. 3 halves to both sides. Now, I can't just go ahead and add these 2 fractions together because they're not like terms. So what I have here is 5/6 k equals, I don't know yet, I need to get common denominators right here to be able to add these. So I'm going to turn them into sixths because 6 would be the common denominator, so I need to multiply by 2. So that's going to be 14/6 plus, this one needs to be multiplied by 3, plus 9/6. 14/6 plus 9/6 is 23/6. And then now we need to divide by 5/6 to solve for k. Now, I don't want to divide by a fraction. Instead, I want to multiply it by its reciprocal. So I'm going to multiply both sides by 6/5, allowing me to get k by itself. 6 goes into 6 once, so I'm left with 23/5. Okay, there's another way to do this problem. I could instead have found the common denominator, which I had to do anyway when I was adding or subtracting, and instead of getting a common denominator during that step, I could have started off by finding the common denominator and multiplying everything by it. We'll try that method over here. For example, the common denominator here is 15. 3 and 5 both go into 15. What I'm going to do is multiply everything by the common denominator. So I'm going to take 15 times y over 3 plus 15 times 2 over 5 plus 15 times y over 5 minus 15 times 2 over 5. Now in each of these, 3 goes into 5, or 3 goes into 15 5 times, 5 goes into 15 3 times, 5 goes into 15 3 times, 5 goes into 15 3 times. In each of these, the denominator will simplify out, and I'll get 5y plus 2 times 3 is 6 equals 3y minus 3 times 2 is 6. By multiplying everything by the common denominator, I'm able to reduce this to an equation that does not contain fractions and can be solved like a regular equation. There are some advantages to that. So when I start to combine my y's, I just need to subtract 3y from both sides. Alright, I've got myself now 2y plus 6 equals negative 6. Then I need to get rid of this 6, so I get my y by itself, so I'm going to subtract 6 from both sides. So 2y equals negative 12, and then divide by 2, we have y equals 6. So again, 2 ways of dealing with fractions. One of them was to just deal with the fractions and have to get common denominators and have to divide or multiply by the reciprocal and just deal with the fractions. And the other way is to get rid of the fractions in the first step by multiplying through by the least common denominator. This would be my preferable way, but both ways work. Okay. Step 3, we are going to solve each of these. In the first one, let's go ahead and distribute. So I've got 0.3x minus 4 equals 0.1x plus 1. Now we can go ahead and combine like terms. Subtract 0.1x from both sides. So it'll give me 0.2x minus 4 equals 1. Now add 4 to both sides. 0.2x equals 5, and then divide both sides by 0.2. X equals 25. Okay. Now the next one, very similar. We could start by distributing. Alright, so let's distribute 2.4 times 1.8. 2.4 times 1.8, 4.32. T minus 2.4 times 3.8, 9.12. Equals 14.64. Alright, so similar to the example where I cleared the fractions, I could also clear the decimals. In this situation right here, since I've got 2 decimal places in all of them, I could multiply everything by 100 to write this as 432t minus 912 equals 1464. You can clear the fractions or clear the decimals by multiplying both sides of the equation by some value. In this case, now I'd be adding 912. So it'd give me 432t equals 4 plus 2, 6, 7, So 2,376